Alright, hi guys, we're going to talk about the linear combination method today. Unfortunately I couldn't come in today, so I'm going to try my best to use my laptop and record this quick video for you so that you can still do your linear combination pathway today. This is the small group instruction portion that I was going to do with the whole class. So, idea of linear combination is that you're combining your two equations. If you combine these two equations vertically, watch, 2x plus 3x would give you 5x. 7y plus negative y would give you 6y. Let me make this a little bit bigger. And then 5 plus negative 4 would give you 1. Now that doesn't really do much for us because just like with substitution, our goal is to get rid of one of the variables and solve for the other. So for this one, we want to make 0 pairs, or for any of these. So see how 2x and 3x, not 0 pairs. 7y and negative y aren't 0 pairs either, but it's a little easier to make this 3x minus y equals negative 4. It's a little easier to make that y into a 0 pair. So if this is 7y, we need this to be negative 7y. Well, it's already negative. So what we're going to do is we're going to multiply the second equation by 7. Right? When you do that, you're going to end up with 21x minus 7y equals 28. It's very easy to not multiply by every piece. It only works if you multiply by every part of your equation. Think about that when you go to do your error analysis. All right, so now we have this equation. I'm just going to copy and paste it down here. And now we can combine it with our original first equation, 2x plus 7y equals 5. Kind of draw a line just so you can see how I'm adding these. Alright, so 21x, sorry, that should say, oh no, that's wrong. 21x plus 2x is 23x. The y's went away, and did I do this right? 7 times 3. Okay, let's just keep looking. 28 plus 5 is 33. I feel like I did something wrong. What did I do? 7 times 3 is 21. 7 times negative 7y. 7 times 4, negative 4. Oh, this should be negative 28. That was my issue. Look, I told you it's really easy to make a mistake. And negative 28 plus 25, is negative 23. So we're going to divide both sides by positive 23, and we get x equals negative 1. Okay? Once you know what x is, it's easy to figure out what y is. Alright, so maybe I'll highlight this because that's important. Okay, so once I know what x is, I can plug x into either of these original equations and solve for y. Let's do the first one. So 2 times 1 plus 7y equals 5. 2 plus 7y equals 5. Subtract the 2 from both sides, and we're going to get 7y equals, I feel like I'm doing something wrong again. Oh, because I plugged in 1, not negative 1. Guys, it's early. Negative 2. Okay, so then we add 2 to both sides, we get positive 7. So y is going to equal positive 1. Alright, so we have solved that system of equations. Look, and I've shown you need to be careful with your positives and your negatives. Alright, you can check your answers by taking these and plugging them back in. That's always a good idea. Just for the sake of time, I'm not going to do that right now. Alright, how can I make this so I can have columns? Insert. Oh well. Alright, let's see if I can do this. So let's look at this next one. X plus 2y equals 9 and x minus 2y equals 4. Now watch, if I just add these vertically, x plus x is 2x. And look, we have a set of 0 pairs for the y's. Hot dog, that's awesome. Alright, so we don't even have to do any of that multiplying stuff. We had to multiply here so that we could have 0 pairs in our y's. Okay, so here I can just add them. So we got 2x, the y's are going to go away because they were 0 pairs, so they're going to eliminate. And 9 plus 4 is 13. Alright, divide both sides by 2, and you're going to get x equals 6.5. And that's okay. It's okay that we have fractions. Alright, now we still do need to solve for y. In fact, let me highlight that like I did the last one. Alright, so now we can plug 6.5 into either of the first equations for x. I'll just do the first one. So we have 6.5, plugging it in for x, so we don't need to write x anymore, plus 2y equals 9. Subtract 6.5 from both sides, so we get 2y equals 2.5, because 2.5 plus 6.5 is 9. Divide both sides by 2, and you get y equals, let's say 2.5 divided by 2. I told you it's early, let's say 2.5 divided by 2 is 1.25. Now, because I got decimal answers here, maybe I will take the time real quick to double check my answers. So here's how you check. I'm going to plug both of those x and y values into both of the equations. So let's do the first one. So does 6.5 plus 2 times 1.25, does that equal 9? So 6.5 plus, well, 2 times 1.25, let me use my calculator real quick. It's going to give me 2.5. Do those add up to equal 9? Yes. Alright, now now let's check the other equation. So x minus 2y equals 4. Does 6.5 minus 2 times 1.25, does that equal 4? So 6.5 minus, oh, I didn't mean to have that highlighted. Okay, whatever. 2 times 1.25 is 2.5. Does that equal 4? Yes. How do I get this to not be highlighted? Do not highlight. Oh, maybe I hit no color. Let's see. There we go. Alright, now this last one. 2x plus 5y equals -1, and 3x minus 2y equals 8. So let's double check. Are there any zero pairs? 2x and 3x, 5y negative 2y? Not going to happen. And unlike this problem, where it was really easy to just multiply one equation by a number to make some zero pairs, see how there's nothing I can multiply times 2 to get to 3, 5 to get to 2. So I'm going to have to multiply both equations by a number. Now, I like that the y's, one's positive and one's negative. So I'm thinking, maybe I can make these into 10s. If I make one a 10 and one a negative 10y, one a 10y and one a negative 10y, then I have zero pairs. So I'm going to multiply the first equation by 2, because then I'll have 10y. But you have to do the whole equation. Okay, so that's going to give me 4x plus 10. Please fit 10y. Oh no. Let me back this up just a little bit. There. That should fit. 10y equals -2. Okay, hopefully I don't make any mistakes here. Alright, and then we're going to need to multiply the second equation by 5. So, this darn highlighter again. There we go. Okay, 5 times 3x, multiplying. This is what happens when I can't just use a smartboard. Okay, 5 times 3x minus 2y equals 8. And you can just draw like an arrow like that. That's what I'm doing. It's obviously easier if you do writing this by hand. 15x minus 10y equals 40. Oh, darn. That's okay. Just back both those up a little bit, and then there. Alright, so now we can see that we have 4x and 15x, so that's not going to go away. But 10y and negative 10y, we have made zero pairs. Excellent. So when I add these up, which I can draw that line if it makes you feel better, just so you can see that we are adding those together. So 4x plus 15x gives me 19x. the 10y and the negative 10y give us 0. And the negative 2 plus 40 is going to give us 38. And look, I'm feeling good about this. It's good to highlight, isn't it? If I divide both sides by 19, I'm going to x equals 2. Oh, but I'm okay with that being highlighted. Alright, let's solve for y, because you're not done unless you've solved for x and y. Look at all my other ones, x and y, x and y. So remember, once you use this method to solve for one of your variables, and again, I like this better than substitution because it's less writing, but you can plug this 2 into either of the equations. So I'll just do the first one, 2 times 2, plugging it in for x, plus 5y equals negative 1, and then we're just simplifying, so let's see, 4 plus 5y equals negative 1, subtract 4 from both sides, so we get 5y, negative 1 minus 4 is negative 5, and then divide both sides by 5, and you get y equals negative 1. Alright, I should check, but I'm frustrated making this video and ready for it to be done. So you check and make sure I did it right. Plug 2 and negative 1 into my original problem. Oh, you know what? The cheat way to check is use Desmos. Yes, you need to show all your work. Will it record this if I go to Desmos? Let's see. Let's see. 2x plus 5y equals negative 1. 2x plus 5y equals negative 1. And the other one was 3x minus 2y equals 8. 3x minus 2y equals 8. And look, 2, negative 1. What did I say the answer was? 2, negative 1. Alright, awesome. Alright, good luck today, and hopefully I will see you tomorrow.